Here are the solutions to the Chapter 6 exercises on arrays. Firstly, the exercise involving strcpy and strcat. Let's have a look at it. Okay, so we get someone to enter their first name and their surname. We store those into variables called first and sur. Okay, each of one's 21 characters long. We need a buffer to store them combined with a space between them. That's going to be 42 characters combined, and some loop counters there. Okay, now here's the guts of the program. First, copy the first name into the buffer in the way that strcpy would. So you need a for loop here. Initialize our loop counter, and we want to stop when this becomes false. In other words, we want to walk along the first array, called first, until we find the null character. And we'll increment our loop counter each time through the loop, and then we simply do a character assignment. That character gets mapped into that character, 1 for 1, and so 0 goes into 0, 1 goes into 1, 2 goes into 2, until we get to the null character. Notice that the null character will not get copied here, because as soon as this equals null, it will drop out. And that's fine, because we're not actually finished building our buffer string yet. So next we add the space. Notice that the value of I, after you finish the for loop, will be set to point to the next character immediately following the characters that have been read in. In other words, the last thing that we do before this test is performed, before this test is performed, is do that increment. So I gets set to the next highest number. An assignment will have just taken place. Let's say the name is Mark, so the K will have just been copied across. The K from there goes into the K from there. This gets moved on to point to the next spot in the array. We find that it happens to be a null, so we drop out. So this space gets added to the next spot in the array, because that's what I will be set to. Now don't forget to actually increment I. You've added another character to the buffer, so we need to keep track of that. We need to keep track of the fact that we actually have moved one space along. Okay, now we do the concatenation. Slightly trickier, but not much. This time we're going to use J as our loop counter, and J is going to walk along the sur, as in the surname string, until that reaches a null. And then we're going to copy the jth element of sur into the ith element of buffer. Can you follow that? If you can't follow that, stare at it for a while, because you will get it. It's not actually that difficult. There's one tricky thing going on here. There's our loop counter being incremented, the j equals j plus 1. But what about this? We've got an I equals I plus 1 as well. Now clearly we need an I equals I plus 1. We've got to walk along our buffer one character at a time, just exactly the same as we walk along sur one character at a time. But I thought there was only supposed to be 3 things in a for loop: an initialization, a condition, and then an increment. And that's true. There is. But notice that all those 3 things are separated by semicolons. Semicolon there, semicolon there. This is a comma. Interesting. You're allowed to do several increments if they're all separated by commas. You're also allowed to do several initializations if they're all separated by commas. You probably didn't know that either. So I could here say j equals 0, comma, and x equals 10 if we had a variable called x, but we don't. So you might think to yourself, well, obviously then, as far as the condition is concerned, this condition here, you can put a comma after that and perform some other condition. X is less than 10 or something like that. Now, the compiler will allow you to get away with it, but it's actually kind of wrong. Because if you really want to have 2 conditions, then join them together using an ampersand, x is less than 10, or the pair of or characters. Those will work probably a lot better than the comma will. It's legal, but not recommended. Okay, so there's the trickiness. Notice that the for loop has 2 increments. Okay. Now, finally, we've added all the characters to our buffer, all except the null character. The null character will not have been added here, because when we reach the null character in the surname, we immediately stop. We don't do a copy at that point. So the buffer will not have a null character on it. So we must add one ourselves. Now we don't really need to increment I just like we did here. We could certainly, but we're never going to use I again, so it's not necessary because we have finished with the buffer. And then print out the full name. Okay, let's see if that works. Compile, okay, and run. Please enter your first name, Mark, your surname, Virtue, full name, Mark, Virtue with a space in between. Okay, so the copy and the concatenation are both working. Okay, now let's have a look at the more important of the two exercises, the course project. Here it is, database.c, this time in the Chapter 6 folder. Okay, so now this is turning into quite a substantial program. We have 132 lines in this program at the moment. Not bad. Okay, so let's see what's been added. Oh, hang on, here's the first thing that's been added. These are now all arrays. We've got 100 titles, and that's a two-dimensional array, notice, because that's an array of arrays of characters, or in other words, it's an array of strings. And the same with the artist, so that's a two-dimensional array as well. We have 100 tracks, we have 100 flags to say whether it's an album or a single, and we have 100 prices. These 100 flags, that's 100 booleans, 100 yeses or nos. Now, very importantly, we need a counter to keep track of how many we've currently read in, otherwise we won't know how many to print out again. And finally, we need a loop counter, but that's pretty straightforward. Okay, let's have a look at the differences between this version and the last version. Notice I put a little warning message out here. You can store a maximum of 100 CDs. Okay, now clearly we're going to have to loop. We're going to have to loop until they decide that they don't want to enter any more CDs. So we don't know at the beginning of the loop how many times we're going to end up going through the loop. So we could use a while loop for this. We could indeed use a while loop. I actually prefer to use a forever loop. Why? Because there is, well, we can have several ways that we can break out of this loop. We could break out of this loop if they ever answer no, they don't want to enter anymore. And we could also break out of this loop if we reach the maximum of 100 CDs. So we're going to have two possible ways of exiting. So I just like to deal with them as they come up. And I don't think it's necessary to put a condition in here. Still, that's a style issue, and that's just my opinion, but you can do it however you like. If you used a while loop or even a for loop, then that would be perfectly okay as well, just so long as it worked. Okay, so let's see what this loop actually does. Ask them if they want to enter another CD. So ask them a yes-no type question, read one character as their answer, and we can use the type variable again for that. It's just a temporary variable. We don't need to store that anywhere. Compare it to a lowercase y or even an uppercase y, and if they did not answer either of those, then break. So we're not really going to go to the trouble of saying you must enter a y or an n. If they enter yes, then we'll go and do it all again, and if they enter anything but a yes, then we'll break at that point. I guess we could be really strict about it, but it's just not necessary. So I'm just going to throw a little new line in there to make the output look neater. You'll see why when we get to the output. Okay, let's start entering details. Now, this is all the same as it was before, except I've told them what number CD we're entering, so they can kind of keep track. If we get up to 85, they may be losing count, so that will let them know. And obviously, here's the juicy part. We're entering data into not just the variable called title, but now title is actually an array of strings, so we want to enter data into just one of those strings, and that one will be specified by the index called count. Now, if you notice, count came from up here, and count was initialized to 0. So right at this point in time, when we get down to this line again, count will be on 0 the first time through the loop anyway. So we'll be reading data into the 0th element of the array, which is exactly what we want to do. And at the bottom of this loop, we will increment count, so that count will be set to 1, and we can go around the loop again. That's also a fairly standard way of doing things. Again, the artist is exactly the same. Next, the number of tracks, again, pretty much the same. Album, single stuff, all pretty much the same. The difference obviously being, again, exactly the same. We need to have we now have an array of flags, an array of booleans, so we want to make sure we just reference the one of them. Again, by using count. Price is exactly the same. Okay, now we get to the more interesting part of the code, the additions. We've got count equals count plus 1. Okay, that's pretty straightforward. We have now finished adding the 0th element, the 0th CD, and now we're ready to increment count, and thus we'll be, next time through the loop, we'll be adding details surrounding the CD number 1, which will actually be, if you think about it, the second CD. So, good, better check that we've filled up the array. Now, if count is equal to 100 at this point, in other words, we've read in exactly 100 CDs, then we're full. The array is full. And we'll put a little message out, and we'll break. Because the next thing we're going to do after that is we're going to print them all out. So we've got one break here if they reach the limit, and we've got another break, if you think about it, up here. Let's scroll up to the top. If they said that or if they did not answer yes to that question, then we break there. So there's two ways that we can break out of this forever loop. It's always a danger with forever loops that they're going to turn into infinite loops, but we have two different possible ways of getting out of the loop. Once if the user tells us that they don't want to continue, and once if we tell the user that we can't continue. Okay, so let's move on. So that is the end of the loop, and that line right there is the actual end of the for loop. So it's quite a long for loop. It's probably 60 odd lines of code. Next, we print all the details out. Now we can just use a straightforward for loop there, pretty much standard, and we tell them that we're printing out the details of CD number what? CD number 1, 2, 3. Notice that we'll actually be counting up from zeros, but we want to be telling the user that we're counting up from 1, so we make a little adjustment there. That's always what we have to do with the language of C. We don't have to worry about it with BASIC or Pascal or those other languages. And every time we output a piece of information, we're outputting the ith element. So I will be 0 at the beginning, so we'll be outputting the first element, and then so on and so on. So that's the difference there. And then we'll just keep going around through that loop. But as a user-friendly sort of option, I've done this bit of code here. I'll ask them to press enter to see the next set of details. I don't want to scroll up, 99 or 100 CD details. They'll only get to see the last couple on the screen. The rest will have scrolled away, never to be seen again. So they can read all the details on the screen, press enter, and they'll see the next set. And that's just a pretty standard get chart. But I only want to do that if there is actually another one to see. So if we get up to, say, 99 and they actually entered 100, then we don't really need to, well, if we get up to the 100th one, shall we say, then we don't really need to tell them to press enter to see the next set, because there is no next set. Now, if you're not entirely comfortable with why this is count minus 1 and not just count, then I suggest that you just have a little bit of think about it, and you'll find that it's true. Finally, we're all done. We've printed out all the details of all the CDs. We can press enter to exit the program. Okay, fine. Let's see if it works. Compile. No errors. Great, 132 lines and no errors. Run the thing. Have you any more CDs to enter? Well, that's not a bad question right at the beginning, because they may not actually wish to enter any CDs from the beginning. So if I said no, press enter to exit the program. Well, that's nice. We should always test that sort of thing, just in case. Any more CDs to enter? This time we'll say yes, and, okay, I don't really want to type in massive numbers of details, so we'll just call this A, and the artist being B, and the number of tracks will be 3, and this will be an album, and the price will be $5.55. And have you got any more to enter? Sure, why not? One more. I don't really want to do 100. I'm sure you'd get as bored as I would. This will be under T, and it'll be by the artist W, one of my favourite bands. And there are 7 tracks. It's a single. Don't know why you'd have 7 tracks on a single, but never mind. And the retail price is $9.99. Have you any more CDs to enter? No. No more. So it now prints out the details of CD number 1. And if you recall, that's exactly what I entered. Press enter to see the next set. And yes, that looks pretty much what I entered as well. Press enter to exit the program. Looks pretty good. Okay, that's it. So that's it. We now have a database a real legitimate database of CDs. It's not particularly functional, as you've seen, but at least it does something more than just enter the